Hello everyone. The title of this video is Finding Domain and Range of Inverse Functions. So every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 3.7, titled Inverse Functions. And I'm under the heading Finding Domain and Range of Inverse Functions. And each example I do will either be one of the examples from the reading, or one of the try it problems from the reading, or one of the exercises at the end of the section related to this particular objective. Alright, so I've got written out here, finding domain and range of inverse functions, and the first example I want to do is the try it problem from the reading, try it number 4. Alright, but before I get into that though, and this is something that I had brought up in my previous video on verifying that two functions are inverses, but this time I'll actually write it out. So given a one-to-one function, and again it's got to be a one-to-one function in order to have an inverse that's also a function. Right, because if a function's not one-to-one, then its inverse will not be a function. Right, that's why we have to have our initial function being one-to-one. And you'll see an example of this later in this video actually. But given a one-to-one function f and its inverse function, right, which was this f inverse, right, f with a little -1 above it, we have the following relationships between their domains and ranges. The domain of f, right, the domain of f, right, all the numbers that are in the domain of the original function are in the range of f inverse. Because if you recall from, again, the previous video on verifying that two functions are inverses, inverses are just reverse mappings. So if a value is in the domain of f, it's going to be in the range of f inverse. Right? So the domain of the original function is the same set of numbers as the range of the inverse function. And the same thing goes, and vice versa. Just switch these up. The domain of f inverse has the exact same set of numbers as the range of f. Right, so the range of the original function f, those values become the inputs, right, become the domain of f inverse, because again, it's just a reverse mapping. That's all inverses are. Okay, so if you keep that in mind, most of this stuff should be pretty simple to follow. Alright, so let's take a look at try it problem number 4 from the reading. So again, you got some reading to do here, notes to take, examples to practice. So here it is, try it problem number 4, a very simple one. It simply states, the domain of a function f is all the numbers greater than 1. Right, so remember the domain is a set of all the inputs, right, the x coordinates. And the range is the set of all the outputs, or the y coordinates, right, if you're looking at a graph. The range of the function f is all the values less than -2, right, but not including -2, right? These are written in interval notation. And we're asked simply to state the domain and range of the inverse function, right, f inverse. Alright, so back on my paper, I'll write out the information we were given. Alright, we're told the domain of f is all the values, greater than 1, but not 1 itself. Right? And the range of f was all the values less than -2, right? But not -2 itself. And that's all we need, right? So for the inverse function, I'll do this in a different color. All right, so the domain of the inverse, right, the domain of f inverse, this little f with the -1 above it, should be the same as the range of f. So from -infinity to -2. Right? So those are the inputs of f inverse. And the range of f inverse, right, the values in the range, the y coordinates of f inverse should be the x coordinates of f. Right, the domain of f is the same as the range of f inverse, so the values from 1 to infinity, but not including 1. And that's all they wanted. Right, that's all they asked us for. So I'll put that in a little bubble. And that's it. Now, a sample, right, an example of a graph that would have this happen. Right, say here was the xy plane. And I'll do the graph of f in this like pinkish color. So remember, the domain of f is everything from 1 to infinity on the x-axis, and the range was all values from -infinity to -2 on the y-axis. So the graph of f could look something like this. Maybe there's a couple. Maybe I'll put in a couple asymptotes. One here at -2, a horizontal asymptote, and I'll put again, this is just a sample. So f could look like this. All right, here's f. All right, the domain is everything from 1 onward, but not including 1. Right, and the range is all the values below -2. And you may recall this from the last video as well. All right, I put this up in the last video. The graphs of inverses are a reflection across the line y equals x, right? So here's y equals x, right? That's got 0, 0, 1, 1, 2, 2, and so on. Just a line with a slope of 1 going through the origin. The graph of f inverse is reflected across this line, and when you do that, here's 1 on the x to 1 on the y, -2 on the y to -2 on the x. And if I do this, I'll put some asymptotes at -2 and 1. I'm sorry about the clutter. You'd get this graph. Right, so I'll do this in like a greenish color. And here would be f inverse. Right, if I were to take this graph here, f reflected across the line y equals x, here's f inverse. And you see the domain is all the values, all the inputs are left of -2. And the range is all values from 1 and up, above 1. So it works out the way I wrote it. Now again, this is just a very simple example of a graph that would have these things happening. You could make up some other examples, I'm sure. But this is what happens in inverses. The mappings reverse. The x's and y's switch. The domain of one function is the range of the inverse. The range of one function is the domain of the inverse. I'm hoping that's clear after this example here, and that'll continue to come up throughout the rest of the video. Okay. All right, so I only have one other example, and it's taken again from the OpenStax book somewhere. Here it is, and we're asked to do the following things. We're asked to find a domain on which function f is 1 to 1. and then find the inverse of f restricted to that domain. So I'll talk about finding the equation for a inverse function. Alright, so look at this function here. You should know what the graph of this looks like. It's the graph of f of x equals x minus 6 squared. It's the graph of x squared shifted to the right 6 units, right? So you'd have 6, 0 as the vertex, and then you'd have 7, 1, 7, 1, and 5, 1 as well, right? Because negative 1 squared is also 1. And it's a parabola. All right, so here it is. This is the graph of f. A bunch of points like that, again, a little parabola shape. Here's the graph of f. Now notice that this does not pass the horizontal line test. So at the moment, f is not a one-to-one function. And I'll say it's not a one-to-one function when the domain is all real numbers. Right, negative infinity to infinity. Because right now the domain is all real numbers. I got the entire graph here. And look at what happens when I draw the inverse. Right? Every graph has an inverse, but not every inverse is a function. Right? So all this means, when I say f is not one-to-one on this domain, this means the graph of the inverse, or the inverse, will not be a function. And watch, right? I'll show you here. So like the original function, right, has 5, 1. Right, here's the ordered pair 5, 1 and 7, 1. So remember, in an inverse, you switch the x and y, reverse it. So 5, 1, you'd have 1, 5 instead. And instead of 7, 1, you'd have 1, 7. And can you see right away it's not going to be a function? Because 1 goes to 5 and 7. And then 6, 0 would go to 0, 6, right? And you'd get this graph. Now I'm not going to call it f inverse. I'm just going to write the word inverse. Because again, it's not a function. See the graph of this green parabola? Not a function. It doesn't pass the vertical line test. Right? So, right? Not a function. So that's why they gave us our first instructions. Right? They say find a domain on which function f is one-to-one. Because right now f, the pink parabola, it's not one-to-one when the domain is all real numbers. Right? So what we have to do is we have to restrict the domain. Restrict the domain, keeping the same range, right? Don't change the range. Restrict the domain, keeping the same range, so that we have a one-to-one function. All right, something that would pass the horizontal line test. All right, so I'm hoping you can see that here, that I think an easy way to restrict this would be to restrict it to from the point 6, 0 and then to the right, this piece of the graph here. All right, just the right half. Now you could also do the left half if you want, but if you just take half the parabola, you're going to get a one-to-one function. So I'm going to restrict the domain to being from 6 to infinity, right? So from the value 6 upward, and the range will still be the same, right? The range is still all the values from 0 to infinity, right? 0 up on the y-axis. And let's see what happens, right? So I'm going to go to another piece of paper. Right. and we'll draw this, right? So we have f of x equals, the quantity x minus 6 squared, but we're only going to draw the part of it on the domain from 6 to infinity, right? So that was this graph here. And I'll actually go to the Desmos website too, and we'll draw this and make a little better picture. So here's 6, right? We'd have 6, 0, we'd have 7, 1, and again, it's just the right half of that parabola. There we go. There's the graph of this f that's being described here. And this is a one-to-one function. Right? It passes the horizontal line test. You're not getting the same output more than once, right, for any input. And since it's one-to-one, that means f inverse exists, right? There is an inverse. The inverse will be a function. Right, and if I draw the inverse, 6, 0 goes to 0, 6. 1, 7 goes to 7, 1 goes to 1, 7. And then this graph here becomes, when I do the inverse, this graph. The top half of that parabola. There's f inverse. And do you see, again, it's not perfectly obvious. It'll be more obvious when I go to the calculator on Desmos, but here's the line y equals x. These are a reflection across the line y equals x. All right. These are a reflection across the line y equals x. Now, what we're asked to do is not only, look at the graph of this thing, restrict the domain. I restricted it to be from 6 to infinity, so we get a piece that's one-to-one, and then we can reflect it across y equals x, take the inverse, and get something that's also a function. But now we're asked to find an equation for f inverse. And here's how you do this. We're asked to find an equation for f inverse. So the first step, if I were you, is in the original equation, right, the equation for the original function, right, where I'll just say y is f of x. Right, so we have that was f of x equals x minus 6 squared, or y equals x minus 6 squared, same thing, where y replaces f of x. In the original equation, replace y's with x's and x's with y's, right? Because that's what happens in an inverse, right? Remember, in the inverse of a function, or the inverse mapping, it just reverses things. X's become y's, y's become x's. So then when I do the inverse, let's say invert, the equation now looks like this. X equals the quantity y minus 6 squared. And then here, in this rule, y represents f inverse now, right, instead of f. All right, back in the original rule, y represented f. But when I switch the x's and y's, y represents the inverse function, f inverse. Oh, and keep in mind that x has to be greater than or equal to 6, right? Remember, we restricted the domain to values 6 or greater. That's going to be important. All right, and then solve for y. Solve for this new y, and that'll give you a rule for f inverse. All right, so here I'd be taking the square root of both sides. So we'd have the square root of x equals the square root of y minus 6 squared. Now remember, this is why I pointed out the restriction on the domain. Hopefully you recall this. This might be from a while back, but remember, the square root of something squared is the absolute value of that thing, which is just that thing itself if it's positive, right? Or the opposite if it's negative, right? Absolute value always turns things into positive expressions. So this is the square root of x on the left equals, the absolute value of y minus 6 on the right, but, y is going to be greater than or equal to 6 here, right? Since x was greater than or equal to 6 in the original. Remember, I switch x to y. And since y is greater than or equal to 6, y minus 6 is greater than or equal to 0. So the absolute value, this is the absolute value of a positive number, which is just itself. Right, so this can end up just being y minus 6. Now if I went to the left half, if I said let x be less than or equal to 6, then this would be y is less than or equal to 6, and you'd be taking the square absolute value of a negative, which would be, negative y plus 6. So be aware of that. Right? And then just simply add 6 to both sides, and we get y equals the square root of x plus 6. And there's our rule for f inverse, right? The y in this rule represented f inverse. So f inverse of x is the square root of x plus 6. And there we go. And this is what we were asked for. What's the equation of the inverse after you restricted the domain, right? And let's take a look. All right, let's take a look. I'll go back. Remember, our original function was this, where the domain was restricted. And then I'll graph this as well. All right, so let me go to that Desmos site. And what we're going to see is a graph like I have by hand here, but it'll look a lot better. So I'll go to that Desmos site. So again, the original function was y equals, sorry, not j, y equals the quantity x minus 6 squared. Alright, but remember, I can't leave it that way because that's not one-to-one. So after, I'll put some braces and say x has to be greater than or equal to 6. Close the braces. Hopefully you remember how to graph. Remember those piecewise defined functions. If you want, if you go back and watch my video on piecewise defined functions and how to graph in Desmos here, this is how with the braces. All right, so here, see, we start at 6, 0. There's 7, 1, and so on. All right, 8. Looks like 8, 4. All right. So on the inverse, you should have 0, 6, and 1, 7, and 4, 8. Right? And you know what? I'm going to put up the line y equals x as well, so we're going to see a reflection across this when we graph both the function and its inverse. And what was our inverse? It was y equals the square root of x plus 6, and then plus 6 after. And look at this. Look at that green. Look at that purple graph and the red graph. And you see how they look like they're a reflection across the dotted line, right? Across the line y equals 6. Or sorry, y equals x. And look, see, there's 6, 0. Here's 0, 6. Right here, this has 7, 1. This has 1, 7. There it is. This has 4, 8, 4. This has 4, 8. They both have 9, 9. Right? That's on the line y equals x, so when you reflect it, it stays there. And yeah, it looks absolutely wonderful. Right. Now, like I said, that's one way I could have restricted the domain. The other way is, what if I let x be less than or equal to 6? Right, so let me talk about that real quick. All right, so what if instead we did this? So instead of looking at the right half of the parabola, like I had here, I looked at the left half. All right, we did this. Started from 6, 0 here and looked at the left half of the parabola instead and called that f. So what if we did this, right? Or f of x equals, x minus 6 squared, but this time I restrict the domain from negative infinity to 6. Right? X is less than or equal to 6. Same thing. All right, so drawing this graph, and I'll do it in Desmos as well. We'd have, 6, 0. But now I can't plug in numbers greater than 6. I got to plug in, 5. You got 5, 1. Plug in numbers less than 6. 5, 1. You'd have 4, 4. Right, and it's just this left half of the parabola. Right, so here's the graph of our f now. Right. So then when I try to find f inverse, right, let's invert. So that's going to be x equals, parentheses y minus 6 squared, but, where instead of x is less than or equal to 6, y is less than or equal to 6, right? I just switch all x's and y's, and then I solve for this new y. So here I have square root of x equals, the absolute value of y minus 6, right? The square root of y minus 6 squared. But y minus 6 is now negative, right? It's not positive. So this is going to be negative y minus 6, or, distributing the negative, that'd be negative y plus 6. That's the opposite of that, equals the square root of x. And then I would subtract 6, get negative y equals square root of x minus 6, and then multiply both sides by negative 1. And have y equals negative square root of x plus 6. There's our rule for f inverse, right? F inverse equals negative square root of x plus 6. This is the rule for the f inverse this time with this restricted domain. And let's see. You got 6, 0 on f, you'd have 0, 6 on f inverse. You got 5, 1, you'd have 1, 5, right? And instead of the top half of a parabola, right, this inverse will be the bottom half of a parabola opening to the right. There's f inverse. And you see the line y equals x, or if I draw y equals x here, these should be a nice reflection across the line y equals x, and it looks like they are. Right. But yeah, the rule is totally changed when I restricted the domain in a different way. Right. And let's go back to Desmos and see that, right? So instead of x being, greater than or equal to 6, I have x being less than or equal to 6. And we get that left half of the parabola there. And then, y equals negative square root of x plus 6 was the inverse. And you see the purple graph and red graph now are definitely a reflection across the line y equals x. So it depends on how you restricted that domain. Right. So you see again 0, 6, 6, 0. There's 5, 1, right? 5, 1. And then this should have 1, 5. There it is, right? And so on. And they both have 4, 4, right? Wonderful. Now you're not always going to have to do this, right? I mean, a lot of times you'll just be given a graph or given a function and asked to find the inverse without having to restrict the domain. Very often, right, in a lot of exercises in some upcoming videos, instead of being given a function that's not one-to-one, you're just going to be given a function that is one-to-one already, and then you just find the inverse. Right? So this is not going to happen as often. Right? This kind of problem here. Alright, well, I'm hoping that watching me go over at least these couple examples help you in some way when you're asked to state, find the domain and range. Oh, you know what? That's something else I should have mentioned. My apologies. My apologies. So back in these, okay, so when I had the original rule was, when I restricted the domain to 6 or more, this graph here, and this was the inverse, right? The domain of f was 6 or more. The range of f was 0 and greater, right? Was 0 and up. So here's the domain and range of the original function. And then look at the inverse, right? Look at the domain. The domain, you see, is 0 and up. The inputs are 0 and greater. And the range is 6 and up. So you see that the domain of the original is the range of the inverse. And the range of the original is the domain of the inverse. Okay, so I just wanted to point that out again. I forgot, I forgot to throw that in there, and I apologize. All right, and then same thing for that last part when I restricted the domain this way. All right, for this function, where I had the domain restricted to negative infinity to 6, the range was still 0 to infinity, right? All the values 0 and up, right? For the gray graph here from 0 and up. So there's the domain and range of the original function. And then you look at the inverse, the green graph here. The domain is 0 and up, right? From 0 onward to the right, which is the same as the range of the original, right? The domain of the inverse is the range of the original. And the range of this green graph is, 6 and downward, everything less than 6, so from negative infinity up to 6 on the y-axis. So you see, same relationship, right? This is always the relationship between inverses. The domain of the original is the range of the inverse. The range of the original is the domain of the inverse. Okay, so just keep that in mind. That was the whole point of this video, so I'm sorry I forgot to mention that. All right. And so again, I'm hoping that watching me go over these couple examples here help you out in some way, when you're asked to state the domain and range of inverse functions on your own. Right. Especially if you're asked to take a function that's not one-to-one and then, cut up the domain, restrict the domain in some way so that it is one-to-one, so that way the inverse will be a function. I'm hoping watching me do this one example at least of that will help you in some way. And thank you very much for watching.